We're now ready to turn our attention to the next round of interesting methods defined in Project Reactor's Mono class. And these methods are going to focus on concurrency and scheduling. And we're going to take a look at these operators which are designed to arrange to run other operators in the designated thread and or thread pools that are identified by these methods. And we're going to talk about the subscribe on method, and we're going to talk about schedulers.single. And these will come and answer some of the questions we had from the last round about how you get things to run asynchronously. So the subscribe on operator is a really, really interesting operator. And what it does is it arranges to run subscribe, unsubscribe, and request. Remember, those are the methods that the publisher and subscriber are using way deep in the bowels of all this stuff on the specified scheduler worker. And the scheduler, which is passed to subscribe on, indicates what thread to perform the operation upon. So you can define the scheduler. You can say what you want it to do. And that's going to have a big impact on the behavior. It returns the mono that is requesting asynchronous processing. So this is how you're going to get things to run asynchronously. There's several ways. This is one of the ways to get things to run asynchronously. Now, the semantics of subscribe on are rather unusual. They're rather odd. And it takes a while to get your head around what they're doing. And it has a lot to do with this concept of lazy factory methods versus eager factory methods. So let's take a look at an example. And I also had way too much fun putting an animation in this so you could see how things go from top to bottom. So if you place this operator in a chain, remember a chain is just a chain of fluent method calls that are being used here. That will impact the execution context for the on next, on air, and on complete signals. Those are the things that are going to be used to emit the values once data starts to flow from a publisher to a subscriber. And so what's going to happen in this particular example, which we'll look at in more detail when we get to the case study here shortly, it's going to use subscribe on to run all the processing in the background thread designated by schedulers.single. We'll come and talk about schedulers.single in a second. It's a factory method that says run this particular computation chain in a single background thread. So that's what that's doing. So we're saying arrange to run this in a background thread. Now what's so weird and funky about subscribe on is you could actually put subscribe on pretty much anywhere in this chain. It needs to come after the factory method, but it doesn't have to come anywhere in particular. It could come after the factory method directly, as we show here. It could come after do on success. It could come after map. It could come after the second do on success. That's what I show here. And no matter where you put it, some other things, all other things being equal, the behavior will be the same. It will arrange to run that whole chain of computations in that background thread. And the reason that it does that is because from callable, remember from callable is this lazy operator, that from callable method is now called in a background thread. So even though we put subscribe on after from callable, it starts from where the chain begins. And that's what makes this just so weird. First of all, it's weird that you put a method that has an impact on something above it in the chain. That's weird. And then secondly, it doesn't matter where you put the method in the chain. I mean, obviously you can't put it at the very, very, very end, but pretty much anywhere else you put it, it'll still have the same behavior. Now, so this is just a forward reference to things we'll talk about later. There's another operator in Project Reactor called publish on. And if a publish on appears after a subscribe on, it then takes preference or precedence over where the computation will go henceforth. So we'll talk about this later when we talk about publish on, but right now we're just focusing on subscribe on. This is just a forward reference to remind us to come back and look at this in more detail. Subscribe on and publish on are probably the most subtle semantics in all of Project Reactor because it's just weird. But once you get your head around it, it's not too hard. RxJava has a subscribe on operator that works exactly the same way that Project Reactor does, which is nice because they're both weird in the same way. So let's talk about one of the scheduler operators. We're going to talk about schedulers.single. And what schedulers.single does is it will host a single-threaded executor service-based worker that will run concurrently with respect to whoever's calling it. So if you put this thing in the chain with subscribe on, then that will cause the chain to run in the background, even though the calling thread was coming from the foreground thread. The calling thread, foreground thread in this case, was arranging to run the computation in this single-threaded executor service-based worker thread. And here's an example of this. This is what we looked at before. So what we're doing here is we're saying, I want to subscribe this chain of operations, right? All these things from callable on down to due on success, map, due on success, and then. All of those things are going to run in a single background thread, and I want it to be this single background thread. Schedulers.single returns that single background thread. This thread is optimized for low latency calls that all run in one and only one background thread. And in particular, it's not intended to be used for blocking calls per se. I suppose you could use it for that, but it's really optimized for low latency calls. And it's implemented by something called a daemon thread. And what that means is if the main thread in the program exits, then all daemon threads will exit too. That's what a daemon thread means. A daemon thread means that you could have a pool of these threads, you could have a single one of these threads, and they keep running until all the user threads, all the non-daemon threads go away, in which case the daemon threads automatically shut down. That's an important distinction for reasons we'll see later on. RxJava has a single method that works the same way. It returns a thread, and it's also implemented as a daemon thread. Okay, so that's an overview of concurrency and scheduling. There's a lot more to concurrency and scheduling that we'll see later on, and we'll talk about why things are done this way. We'll also talk later on about why we differentiate between schedulers and monos and fluxes. So you'll see in the Project Reactor class design, monos and fluxes are their own classes with their own methods, their own semantics, and they both use schedulers, and they both can use the same set of schedulers in order to have things run in the background. And the reason that they work that way is that way we kind of factor out the scheduler logic into one class hierarchy, if you will. And then those same set of schedulers can be used either for mono or flux semantics, rather than tightly coupling them into mono and into flux, in which case we duplicate the scheduler functionality everywhere, which would be less normalized and less clean, less refactored.